Okay, so we are on page 16 of the packet, and today we're going to talk about angles. So an angle is formed by two arrays that share a common endpoint. So here's our two rays, and they both share the endpoint B. This common endpoint here, we call it the vertex. And then the rays are just called the sides of the angle. The way to name an angle is using 3 letters. The key here is that the middle letter must always represent the vertex. So for example, we could call this angle ABC, or you could call it angle CBA. Remember, we always name the angle the way that we trace it. So you would go from A to B to C, or from C to B to A, and that's why B has to be in the middle. Sometimes you can use just the vertex, but it kind of depends on the situation. So the types of angles, I'm sure you have seen these before. If you have an angle that is measured less than 60 degrees, then we call that acute. I'm sorry, not less than 60, less than 90 degrees. We call that an acute angle. An angle that is greater than 90 degrees is called an obtuse angle. An angle that has a corner, right? It's 90 degrees exactly, is called a right angle. And an angle that is straight, like a straight line, is 180 degrees. We actually just call that a straight angle. If at any point you need to pause the video and catch up on the notes, that's totally fine. You have enough time. Okay, so if we were going to look at this angle here, first of all, they want the vertex. So the vertex is the middle letter, which is K. The sides are always going to be rays, starting at the vertex. So one side would be KJ, ray KJ, and remember we draw a little ray above it. The other side would be KL. And again, we draw a little ray above that. Okay, 3 ways to name the angle would be, again, how you trace it. So it could be JKL. It could be backwards, LKJ. Or in some cases, you'll be able to just call it angle K. Classify the angle means, is it acute, obtuse, right, or straight? In this case, we can clearly see that this is more than 90 because it's bigger than a corner, so we would say this angle is obtuse. So what I'd like you to do now is pause the video, try the next problem, and then resume and check your answers. Okay, so example 2, vertex is point S. The sides, I actually wrote this one wrong. I'm sorry. It should be SR because it has to start at the vertex. Good way to learn from mistakes, right? And ST. 3 ways to name it are just angle S, RST, or TSR. And it has this corner there telling you it's 90 degrees, so it is a right angle. The same way we worked with congruent segments, we will also work with congruent angles. So we say if the measures of 2 angles, like A and B in the picture there, are equal, then the angles themselves are congruent, meaning same shape, same size. An angle bisector, remember, just like a segment bisector, bisect means to cut in half. So an angle bisector is a ray that divides an angle into 2 congruent parts. In the diagram to the right here, ray BD is bisecting angle ABC. Therefore, we have 2 congruent angles here. ABD, we could put a little mark in them, is congruent to angle CBD. Our next new vocab term is perpendicular lines, which hopefully you've heard perpendicular before. They always cross at right angles. So they cause all these 90s in here, right? 90, 90, 90, 90. So two lines that intersect at right angles. The symbol for perpendicular, you've probably seen it before, is going to be this little upside down T. So in the diagram to the right here, we could say that line L is perpendicular to line M. And this is just like our shortcut way of writing perpendicular because it's a long word. A perpendicular bisector is something that, the lines will meet at right angles and one of the lines will cut the other one in half. So it's a line, a segment, or a ray, perpendicular to a segment at its midpoint because it should be cut in half. So in the picture here, line LM is cutting line PQ in half. So LM is the perpendicular bisector to the segment PQ. And be careful with your notation. We're going to skip down to example 4. We'll do this one together. So we want to look for the vertex of angle 2. So here's angle 2. The middle letter is T. Okay, the sides of angle 4. So we have ray TW and ray TZ. Another name for angle 3. You could call it ZTU or UTZ, either way, as long as T is in the middle. Similar for angle 1, we'll call it YTX or XTY, as long as T is in the middle. Let's do XTY. Now when they're asking you to classify, that's based on the size. So angle YTW is here, and it's that nice 90, so that one is right. Angle YTU is here, and that one's bigger than 90, so that's obtuse. I'll get some different colors. Angle XTU is over here. It's smaller than 90. It's acute. And angle WTX. WTX is this whole straight line. So that means this whole thing is straight. Okay, two perpendicular lines. I would take these two where I see that clearly it makes 90 degrees, right? So we could call this line YZ or line YT. It doesn't matter as long as it's with two letters. Is perpendicular to line, and we can call it WT or WX or TX. Let's call it WX because they meet at 90. And then an angle bisector. We see here that these two angles are congruent, 2 and 3. So we could say ray TU is actually the bisector of that big angle, XTZ. Let's say ray TU. If you wanted to, you can even say ray TY is a bisector because it's splitting this into angle 1 and angle 5, which are both 90. So there's a few angle bisectors in this picture. Okay, so what I'd like you to do now is again pause the video and go back, try example 3, and then resume. Alright, so for example 3, another name for angle CBF could be FBC. In this case, you can't just call it like angle B because there's so many angles here. There's 1, 2, 3, 4, 5 angles that have angle B as the vertex, right? The sides of angle EBD are ray BE and ray BD. Angle ABC is straight. An obtuse angle, there's many. I said here CBE. You could also say angle ABF. two congruent angles. Here we have the marks, right? So ABE and this should actually say CBF, sorry, or FBC. You could even say that these two angles are congruent because you know that these are both 90s. You could say angle ABD is also congruent to angle CBD. And then a perpendicular bisector would be this one here because it is perpendicular, creating these right angles, and it's kind of cutting this straight line in half. That's right, BD. Okay. And then finally we have a little bit of angle addition postulate, which basically says that if you have two angles that are forming up another angle, if you add them together, they're going to equal the big angle. So we have like this little one, we have this little one, and they should add up to the big one. And I'm doing different tick marks here just to show that they're all different. So this one has 2, this one has 3 marks, and that one has 1 mark, just to show that they're not the same as each other. So we would say the measure of angle ABD plus the measure of angle DBC, right? This small one plus this small one equals the whole thing, angle ABC. Which will make a little more sense when we have our actual picture. So here, let's try this by putting the numbers in. So measure of angle ABD is 48 degrees. DBC is 78. And they want the whole thing, ABC. So it's just going to be the combination of 48 and 78, which is 110 and 16. So that's 126. And then I'll use a different color for the other one. So now using the same diagram, now they're saying DBC is 74, but we're ignoring all that blue stuff. ABC, the whole thing they're telling us is 119, and they want to know what's this other little one. So there you're trying to figure out like what plus 74 gives you 119. And then the answer for that would be 45 degrees. Okay, now the next one, we don't have actual numbers, but we do have the expressions. So PQS is 13x plus 4. RQS is 10x minus 1. Don't forget to read and label this, right? So you always want to have a picture. Label the picture, the most important step. Then you're looking for what's the relationship. And then you can go write your equation. So here this whole thing is 141. So our equation for this one is simply going to be adding them together to 141. Because we can see this plus this equals the whole thing. So 13x plus 4 plus 10x minus 1 equals 141. Then you're just doing your algebra. So 23x 4 minus 1 is 3. 141. Subtract the 3. 23x equals 138. I believe it should be 6. Because 6 times 20 is 120. 6 times 3 is 18. 120 and 18 is 138. So x is 6. And then when you're finding these angles, you're just plugging 6 back in for x. So PQS will be 13 times 6 plus 4. 13 times 6 is 60 and 18. So that's 78, and 4 would give you 82 degrees. SQR is 10 times 6 minus 1, which is 60 minus 1, so that's 59 degrees. And just make sure that you kind of do a little check. They should add up to 141, so that's 130 and 11, so that's 141. Okay, so if you have any questions, like as of now, you can definitely email me. I'll try to check as much as possible. If not, you may start your homework, which is going to be number 4 and 5 on this page. And then you're going to scroll down to page 20 and do number 1. And then again, if you have questions while you're working, please feel free to just email me a picture of your work, and I should hopefully be back tomorrow. Alright, so enjoy the rest of your day. Let me know if you